Okay, so just wanted to go over and give you another look here at how to keep track of all 6 trig graphs. 3 of them, sine, cosine, and tangent, you just need to know cold. For example, you need to be able to sit here, and if I ask you to graph a period or 2 or 3 or whatever of a sine graph, basic sine graph, you know you start at 0, 0, you go up to 1, down to -1, and your period is 2 pi. And that you've just got to be able to, pretty much by right now, that you generate. Now, how did we do that? Well, we went through and we considered an angle in standard position, and we twirled it around in the counterclockwise position. We saw what the y-coordinate did. As the terminal side went up, the y-coordinate got bigger. If we were on the unit circle, y over r meant your sine value was your y-coordinate. When you got up to pi over 2, for example, you got up to a y-coordinate of 1, and that's why we had pi over 2 comma 1. So again, at this point, though, sure, you should be able to understand that, duplicate it if need be, but you know what your basic sine graph looks like, and that's what it looks like. Now, how do we get a cosecant graph from a sine graph? I don't myself memorize anything other than sine, cosine, and tangent, because if I need to graph one of the other curves, I can do it. So, if I want to graph the cosecant graph, the first thing that I do is say, all right, let me create the sine graph as a dotted line, and let me remember what happens between the relationship between sine and cosecant. And the answer is they're reciprocals. The sine, we remember, is y over r, and the cosecant is r over y. So clearly the reciprocal of an output of 1 is 1, and the reciprocal of an output of -1 is -1. So I know there's some points that the sine and the cosecant graph are going to share in common. I then want to consider reciprocals of 0. And if I've got the sine graph here, reciprocal of 0 does not exist, and that's where my asymptotes are going to be for that cosecant graph. So everywhere where the sine graph is 0, the reciprocal of 0 does not exist, and that's going to give me some asymptotes. And then I think through, what's the reciprocal of a very small positive number, say here or here? The answer is a very large positive number. So if I reciprocate those small numbers, small positive numbers, they become large positive numbers. Ditto down here on this side of my sine curve. Reciprocals of very close to 0 negative numbers are going to be very tiny negative numbers, so I'm going to pop down and have an arch that opens down there. And for every arch kind of above or below the x-axis, I'm going to have these reciprocating arches that look like so. And now once you've graphed, once you've gotten that done, you then, if you wish, you can certainly erase your sine curve that you used to help you generate those arches, and you want to leave, obviously, and label your asymptotes. So our asymptotes here would be x equals 0, x equals pi, x equals 2 pi, x equals -pi, etc. So you want to label your asymptotes, and then I want to look at the period here. What's my period here for the cosecant graph? Well, clearly it's the same as the period is for the sine graph. I'm going to have an upward arch and a downward arch. Upward arch, downward arch. Though that upward, downward is going to repeat every 2 pi units. So my period for cosecant is 2 pi. My domain are all real values except for pi, multiples of pi. I can't put in any multiple of pi. My range is my outputs are either greater than or equal to 1 or less than or equal to -1. Now, how would I deal with any horizontal shrinks or stretches or any vertical translations of a cosecant graph? The same way I would deal with those same translations or horizontal stretches or shrinks with any graph. Replace x with 2x, I'm going to have a horizontal shrink by a factor of 1/2, etc., etc. So, looking at the cosine and secant graph, I've sketched in here kind of a dotted version, if you will, of the cosine graph here. And if I reciprocate it, reciprocal of 1 is 1, reciprocal of -1 is -1, reciprocal of small positive numbers, large positive numbers, reciprocal of negative numbers close to 0, negative numbers heading down to infinity. Looking at asymptotes where the cosine graph is 0, that's going to give me my vertical asymptotes. And I note that from -π/2, that's the left side of an up arch, to the right side of a down arch at 3π/2, my period of the secant is 2π. These are arches, they're not parabolas, they are simply arches, they're cosecant or secant arches, and the period's 2π. Same thing for domain and range. My domain here for the secant graph is I can't put in any multiple of π/2. π/2 will not work. 3π/2 won't work. 5π/2 won't work. I can't put in any multiples of -π/2, -3π/2. So these π/2 things aren't going to work. They're outside of the domain. My range, similar to cosecant, I can get values out that are bigger than 1, or I can get values out that are less than -1. I can't get values out in between -1 and 1. So, looking at tangent and cotangent graphs, we remember that the tangent graph, when we generate it, we talked about how it is what it is. We remembered that you had asymptotes at -π/2 and +π/2, and it was a snake that rose from left to right. Clearly the tangent is 0, the y-coordinate is 0, 0, and so 0 over 1 is 0, so your tangent graph passes through the origin. The period is pi, so if I wanted to go over and find the next asymptote, if I go over pi units from π/2, I get to 3π/2, and I could create another snake, if you will, another period of that tangent graph. When we looked at finding the period for our sines and cosines, looking at the coefficient of replacing x with, say, 2x or x with a third x, we looked at something like 2π/b equals p. That does not work with the tangent graph because the tangent graph's period is pi. So when I do a horizontal shrink or stretch, you're going to try and find the period or try and find the coefficient. Remember, it's π/b is going to give you your period. Let's go ahead now and take a look at generating the cotangent graph from scratch. So let's take a look at our cotangent graph, and we're actually going to graph it from scratch. Let's consider our angle here in standard position, unit circle. So 1, -1, 1, and -1 here. And let's consider we've got our angle here that we're going to start spinning around in the counterclockwise direction, heading from 0 to π/2. We know at 0 radians, our coordinates on the unit circle are going to be 1, 0, and we know that the cotangent, we remember, is x over y. So x over y at 1, 0 is going to be 1 over 0. That's undefined, and that indeed is going to give us an asymptote here at x equals 0. Now what happens as I spin up? If I come up a little bit, my y-coordinate is going to be pretty tiny. My x-coordinate is going to be pretty close to 1. So I've got then again a number pretty close to 1 over a very tiny number close to 1 over a very tiny number, and that's going to give me a huge number. So very close to 0, I'm going to be up here at a pretty big number. What happens as I come down? Well, when I hit pi over 2, my coordinates are 0, 1, and x over y would be 0. So I'm going to come down, and at pi over 2, I'm going to hit 0. As I keep spinning around, I then head over toward pi. At pi, it's negative 1 comma 0. X over y would be negative 1 over 0. That's undefined. So I know I'm going to have at x equals pi another asymptote. And furthermore, what's going on with an angle that's over here, say really close to 180? My y is positive, very tiny. My x is around negative 1, let's say. Negative 1 over a very small positive number is going to be a very small negative number, meaning heading toward negative infinity. So I'm going to go down and do something like that. And that gives me one period of the cotangent graph. The cotangent graph differs from the tangent graph in that it falls from left to right, number 1. Number 2, its asymptotes are different. Its asymptotes are every pi units. So multiples of pi and pi give me my asymptotes, and I fall from left to right. And in between those pi intervals, I'm going to hit the x-axis. And again, the cotangent is x over y. So if my angle's in standard position and the x is 0 and the y is some other number, clearly that's where I'm going to be crossing the x-axis.